Okay, this is a typical question of what I might ask you on your periodic table test. What is the electron configuration of Mercury? To answer this question, there's a mnemonic you can use where you write the numbers 1 through 8, and you write the letter S next to each number. Then you skip the first two numbers and you write 2, 3, 4, 5, 6, 7, and you write a P next to each one of those numbers. Then you skip two numbers and you start 3, 4, 5, 6. You write D next to those ones. Skip two more numbers and you write 4 and 5. Leave the letter F next to those ones. So these arrows tell you what order to follow when you fill the shells of the electrons. And recall that an S orbital holds a maximum of 2. P orbital holds a maximum of 6. D orbital holds a maximum of 10. F orbital holds a maximum of 14 electrons. Now, the pattern is not followed perfectly every time, but by and large, it will follow this pattern. Mercury has 80 protons, so a neutral mercury atom is going to have 80 electrons. So one of the things to look for on the periodic table when you're drawing the configuration is find which period Mercury is in. Mercury is in 1, 2, 3, 4, 5, 6, period 6. So once you hit S2, 6S2, which is the configuration of barium, you know that you're going to have to traverse all of D block, so you have to go to D10, whatever the number is, I don't remember because I don't have it in my head. Once you get to D10, right after barium, you know you have the configuration of Mercury. So let's do it now. Follow the pattern. 1S2, 2S2, 2P6, 3S2, 3P6. So every level fills up until you get to the point where you've used up all the electrons, which will be at D10 right after 6S2. 3P6, 4S2, 3D10, 4P6, 5S2. At 5S2 we're here. We're at barium. Sorry, we're at strontium. So we're going to go some more. 5X2, 4D10, 5P6, 6S2. Now we're going to traverse all of F block, go all through F block, 4F14, 5D10 should bring us to the configuration of Mercury, and in fact it says on the periodic table 4F14, 5D10, 6S2. Sometimes they flip around the energy levels because in fact, even though the number is bigger, the energy level is at a lower level. So this is the electron configuration of Mercury, the longhand way. Now there's a shorthand way of writing it as well. What you do is you choose the closest noble gas that is below the element in question, which in this case is xenon, and you write xenon in a square bracket. You bring it up to 5P6. So xenon in a square bracket with the remainder of the configuration, 6S2, 4F14, 5D10. That's your shorthand version of the same thing. So you can save yourself writing all this. Okay, this is the full version, accounting for every single electron. This is a shorthand version where you just use the bracketed closest noble gas.